In high stakes professional environments, especially complex adaptive systems like human biology, financial markets, and large scale manufacturing, we often interpret endless challenge as the default state. We assume complexity requires equally complex, constant intervention. However, the most effective way to navigate volatile systems is to apply this mental model by finding equilibrium points. So, equilibrium point is a specific state within a system where all the opposing forces are balanced. In practical terms, it is that hidden stabilizer, the unique intersection where stability occurs despite dynamic change. This model isn't about aiming for a dead stop, it's about identifying the steady states that are statistically predictable. They are the sustainable anchors in volatile environments. So, why this mental model really works? Because complex systems always seek a stable center. This pull towards stability is a fundamental law. While the rest of the world is chasing disruptive, erratic changes, mastering the equilibrium point gives you massive strategic leverage. And diminishing volatility works in your favor. Extreme, naive strategies that push a system far from its center create massive internal stress, leading to fragility and inevitable collapse. They rely on luck. Predicting an equilibrium point is more reliable than predicting the timing and direction of the next explosive deviation. Mastering this model means you stop fighting the system's nature and learn to work with its inherent pull towards the center. Equilibrium is reliable, extreme volatility is not. Let's take an example to understand this. Imagine you are a part of the clinical development team that's moving a highly potent kinase inhibitor for solid tumors into a phase 2 trial. Early in vitro data showed a high dose achieved 95% efficacy. So the initial strategic impulse would be to rush that specific highest dose into a trial to guarantee success. However, the biology pushes back. The extreme deviation of that dose doesn't just kill the tumor, it also triggers a massive negative feedback loop in healthy cells, leading to severe grade 4 toxicity. The potential miracle drug dies in the development because it didn't account for this automatic pushback. So, what's the robust solution here? Relentlessly hunt for the therapeutic equilibrium. Identify the exact lower dosage intersection that achieves, let's say, for example, 70% tumor reduction, which is a dynamic balanced state where efficacy is substantial but manageable and healthy cell resilience is also preserved. The successful drug isn't the most powerful one always, it's the one that finds the sustainable intersection between safety and efficacy. Also, imagine, let's say, a process engineer who is scaling up a complex monoclonal antibody production from a 5-liter volume to 2000 liters of bioreactors. In the massive reactor, the nutrient delivery and agitation, shear stress are critical variables that vary wildly. If you try to maximize agitation, which is needed for nutrient mixing, the cells might rupture and die. And if you maximize the system for gentle mixing, which can protect the cells from getting ruptured but minimize the nutrient delivery. So the results are either nutrient deprivation or widespread cell death. So the success in finding the process equilibrium, and there's a precise mathematical intersection between the minimum agitation speed required for constant mixing and the maximum speed that cell viability can tolerate. Finding this stable intersection creates a consistent, reliable manufacturing process that ensures scalability and high yields. Complexity is fragile. Equilibrium is sustainable. The goal is not eternal volatility or absolute dominance, but finding the stable intersection of forces. In your next research project or budget negotiation or process changes or updates, stop focusing on infinite disruption and ask, where is the hidden equilibrium point and how can we guide the system towards a sustainable state? Shave away the volatility and guide the system. Master the balance to master the outcome.